Okay, so in the chat says the two numbers should add up to 4 or -5. So the top number we want them to multiply to, and the bottom number we want them to add to. So they should add to -5. And so just looking at this, anytime that you have a positive number on top of your x and a negative number on the bottom, and you're trying to think of two integers such that they multiply to give you a positive, but they add to give you a negative, that tells us they both have to be negative. That's the only way we're going to get it to work. And so 1 and 4, if this was just 5, then that would be good, but we have -5. So it's not just 1 and 4, but this is correct here, -4 and -1, because if I multiply these, I'm going to get +4. If I add these two, I get -5. So it doesn't matter which side you put the -4 on and the -1 on, but no, this isn't working. All right, so we use that magic X to help us figure out the factors. And then we can write out the factorization of the left-hand side of this equation. So one factor is x -4, and the other factor is x -1. And that's equal to 0. That was the second step. Your third step that we had is to set each of these equal to 0. So we're using the zero product property that if you multiply two numbers together and your product is 0, one of those numbers has to be 0. So that means either x -4 is 0 or x -1 is 0. So you can drop the parentheses and type or write x -4 equals 0 or x -1 equals 0. And then your fourth step here is to solve both of these equations. And that would give us our two solutions of what x could be. Let's see if we have some people that figured out what x is either equal to. One of two things. So x could be 1 or x could be 4. This is correct. And I'm using the subscripts here. That's okay. You can do that. X equals -4, -1. So now it is tempting to go right from finding the factors. Oh, they switched it. So it's actually the opposite signs of those two. Was that yours, Angel? Yeah, so right here, x equals 4. Oops. Or x equals 1. Okay, and you can always check your work too with these. You can plug in and see if you do get that answer. You can check the work. So to do that, if I replace the x with a 4, now what is this equal to? It should be equal to 0. I want to make sure that it really is. So 16 minus 20 plus 4. 16 minus 20 is -4 plus 4. And that does really equal 0. So it checks out for x equals 4. And then you could try it for x equals 1. One squared is 1. 5 times 1 is 5. 1 minus 5 is negative 4 plus 4, and that is actually 0. So it checks out with both of them. That's how you can make sure you're doing this correctly. Right, so those are both possible answers to that polynomial. So just like we kind of broke Monday and Tuesday into 2 days, where one day we were just factoring an expression, and then Tuesday we're actually solving an equation by factoring expression, we're going to do the same thing today. So we're just going to be factoring expressions today where the coefficient on the x squared term isn't 1. And then tomorrow we'll solve equations where you have a number here in front of this x squared term. All right, so this is it. This is Unit 5, Lesson 21.2, solving equations by factoring ax squared plus bx plus c. Learning goal, I can factor quadratic expressions. I can solve quadratic equations by factoring to reveal the zeros. So we'll focus on the first learning goal today and on the second one tomorrow. And so there's a method to doing this called the bottom-up method. And I'm going to show you some of this video, which does a pretty good job of explaining how to do this. And we're going to use this method just like she is in this video. I'm going to have to change how I'm presenting here so that way you can get the best audio.
Where the a value, which is the coefficient of x squared, is greater than 1. Okay, so this is an example of a trinomial where the a value, which is this number right here, is something other than 1. So in the past, the trinomials we factored has an a value equal to 1, and we use that magic x method. But here, we have to use a different method. Magic x won't work. So one method that we can use is called the bottom-up method. So the first step of the bottom-up method is always to take this starting coefficient, and we're going to temporarily multiply it to our last number. So here's what we have. Now this remaining trinomial we can actually factor using magic x. So remember, for magic x, we take our last number and we put it on top, negative 15, and our middle coefficient, negative 2, goes on the bottom. And we're looking for two numbers that multiply to make negative 15 and add to make negative 2. So those two numbers must be negative 5 and 3. Those are the only two numbers that work. In fact, you can't even say positive 5 and negative 3 because that would not add up to negative 2. So those are the only two numbers, and those are going to be part of our factors. So now I can write p minus 5 times p plus 3. But now there's one extra step, and this is the step that you absolutely cannot forget. Whatever number you multiplied at the beginning, we're now going to divide it out here and here. So I'm going to write it like this. You have to remember to divide it back out. We multiplied at the beginning, we divide it out here. Now, I'm going to look at each fraction we've created. If you have something like this where the fraction can be simplified, we're going to simplify it. 3 over 3 is just 1, so we have p plus 1. However, if you have something that cannot be further simplified, like 5 over 3, this is where the name bottom up comes from. We take our bottom number and we bring it up in front of the p. So 3p minus 5. And those are the two factors. So once again, if you see a coefficient other than 1 out front, you can't go straight to magic x. However, if you use this bottom-up method of multiplying it away and dividing it back out later, in that middle step, you can use magic x. All right, let's try one more together. So I see there's a coefficient in front of n squared, so I'm going to take it and temporarily multiply it to our constant in the back. Now this trinomial I can factor using magic x. So what two numbers multiply to make negative 18 and add to make positive 3? So that will be 6 and negative 3. Those are the only two numbers that will work. So we do n plus 6 times n minus 3. And now is the part where we have to divide that number back out. Now notice this time the number was 2, so now we're dividing out 2. Now, this first fraction that we've created, we can simplify. 6 over 2 is just 3. However, this second fraction we've created, you cannot simplify it. So now we're going to bring our bottom number up in front of n. So it becomes 2n minus 3. There you have it. All right, go ahead and pause the video and give this problem a try. Okay.
All right, so I am going to stop the video right there. You can always go back and rewatch that video or watch the rest of that video so you can see some more examples worked out. Okay, but that is the method we're going to be using today. And so I took what she was doing in the video and tried to break it down into numerical steps for you so you have something that you can refer to if you get kind of stuck here. So these are the steps for this method. It's the bottom up method. And so the first step is to multiply the coefficient of the x squared term by the constant term. And that's what you saw in that example. She circled what was in front of the first term in that polynomial, and then she multiplied it with the last term. The next step then is to factor that resulting x squared plus bx plus c expression. That's what we were practicing Monday and Tuesday. Okay, and we just did it in our warm-up as well. So that's like what you've already learned how to do is step 2. Step 3, because of step 1, you have to do step 3. So if you multiplied by this number, you have to divide it out so you put your equation back in balance. We're going to divide out the same factor from step 1 out of both constants. So once you've factored, you're going to have 2 binomials, and then each of those binomials has a constant term. You would divide out whatever you multiplied by from both of those numbers. It's important that you then simplify those constants on both binomials. And then because of its name, the bottom-up method, the last step is to move any remaining denominator from the bottom up to in front of the x term. Okay, so that's what she was doing in the videos, and we're going to do that too. So we're going to factor 6x squared plus 5x plus 1. Is that my kid? Yeah. Winner. Okay. All right, so here we go. We're going to do that first step. Yeah, go right ahead. If any of you guys want to get a marker, you can get one too. So the first step here is I'm going to circle what's in front of the x squared, the terrible circle. And I'm going to draw an arrow coming over here, and I'm going to multiply. That's a terrible M. That looks more like an M. All right, so step 1 is to do that. So I'm going to rewrite this as 6 x squared plus 5x, and then 1 times 6 gives me 6. So now I have something that looks like what we were working with on Monday. And we're going to factor this. So the second step is to factor x squared plus 5x plus 6. So step 2, we're going to use our magic x here to factor. We want to take this number and put it at the top of the x, and whatever's in front of the whatever is in front of that x term, we put at the bottom. And now we need to think of a pair of numbers that would multiply to give us 6, but add to give us 5. Either in the class or online, can you guys think of two numbers that when you multiply them, you get 6, but when you add them, you get 5? 2 and 3. 2 and 3.
Does it matter what order they go?
Huh?
Does it matter what order they go?
No, it doesn't. So you could have 2 and 3 or 3 and 2. And Mauricio got that as well right here in the chat. So I could put 2 on this side and 3 on this side, or 3 on the other side and 2 on the other side, okay? But they do multiply to give me 6 and add to give me 5. So my factored form of this expression is now x plus 2 and x plus 3. So this is also step 2, those two things. Use the magic x to factor. Now that we've done that and we've broken it apart into 2 factors, we're going to do step 3, which is to take the same number that we multiplied by and divide it back out. So we multiplied by 6, so I want to go ahead and divide out 6 from both constants on both binomials. Step 3. Step 4 is to simplify. Okay, so I want to simplify the fractions that are now here. So 2/6 is a fraction that simplifies to 1/3. And 3/6 is a fraction that actually simplifies to 1/2. So step 4 here is to simplify those fractions that you got in step 3. Our last step, step 5, is to take any number that's left in the denominator and bring it up. It's the bottom-up method, so I'll just use a different color here. Let's use purple. Okay, so last step here, we're going to take this 3 and bring it up. We're going to take this 2 and bring it up. So this is the last step here. This is step 5. So our answer is going to turn into 3x plus 1 times 2x plus 1. And that is the solution. You can check your work too. So when you're doing these problems and you want to check that you've done it correctly, when you multiply 2 binomials together, you can use the FOIL method, where you multiply the first terms, the outside terms, the inside terms, and the last terms. And so if you did do it correctly, you should come back and get your original polynomial of 6x squared plus 5x plus 1. FOIL, so F stands for your first terms, which means 3x times 2x, which is 6x squared. O stands for outside terms, 3x and 1, which is just 3x. I stands for your inside terms, 1 and 2x. which is just 2x. And L is the last terms. 1 times 1 is 1. So from these guys right here, they're like. So they're actually equal to 5x. But the polynomial that results is, you see, 6x squared plus 5x plus 1. And it checks out because that's what we started with. I was just checking our work on here. So there's a lot going on with these problems, but if you follow the steps, it'll work out. Okay, so I do have one for you to try now. I am going to put you on student pace mode. And if you want to go back and watch that video again and see some more examples worked out, you want me to answer any questions, do that.
What can I use?
Oh, paper towels are back there, so you can grab some. They're like behind the container. There's a big roll, just rip some off. Well, there you go. Yeah, so I'm going to leave this being projected, but you know, here's where you're starting. 4x squared minus 8x plus 3. And so we still have some time left in class, but get as far as you can on this. You can go back through the slides, go back to the steps. You can go back to the video and watch some of that. So see how much you can get done. I'm going to leave my screen up on that one. Yeah, do you guys have questions about anything? Like where numbers are coming from?